When inventory levels, supplier details, and item movements are tracked across disconnected spreadsheets, it might look like a system on the surface, but underneath, the business is actually running on manual updates, delayed reporting, and guesswork. The most common mistake makers make building their first inventory app is creating one massive table. They try to put products, vendor information, and every single stock update into a single flat spreadsheet. When that list grows, tracking the history of a single item becomes impossible. To build an application that scales, we have to move away from flat files and establish a clean, relational data architecture using SharePoint Online. Step 1 is setting up our backend storage. Over the next 5 minutes, we are going to construct 3 specific SharePoint lists and physically link them together so they can share data. By separating out what we track, the actual inventory items, the people who supply them, and the movement of those items, we eliminate duplicate data entries. Designing this structure first is the only way to ensure our Power App accurately calculates stock and prevents negative inventory down the line. This entire system relies on 3 interconnected SharePoint lists: a suppliers list for vendor details, a products list for our master inventory, and a stock transactions list to log every movement. This diagram shows the 3-list architecture and its required build order. We start with suppliers on the left, move to products in the middle, and end with stock transactions on the right, so that each downstream list can pull data from the one built before it. If you try to build the transactions list first, it has nothing to look up. The downstream lists require the upstream lists to exist so they can securely reference their data. These connections establish the irreversible rules of relationship between our lists, ensuring that every data point has a fixed, logical place within the system. We begin at the origin point, the suppliers list. This holds our vendor master data. To make this functional, we need to add specific columns. Alongside the supplier's name, we need contact email to send reorder alerts, lead time days to know how long shipping takes, and status to track if a vendor is active or inactive. Every column must be assigned an exact matching data type to function. The email is a single line of text, the lead time is a number, and the status is a choice field. You can always add extra notes or rating columns later, but these core fields are required for the automated alerts and reporting to work properly. By keeping vendor details isolated in this single origin list, we guarantee that when an app user creates a new product, they select an existing vendor instead of typing in a duplicate or misspelled name. Now that the vendors exist, we move to the second tier, the master products list. This represents our actual inventory. Here, each row is a unique item. We establish columns for the product ID, the category, the current stock available, and a reorder point, which is the minimum stock level that will trigger a warning. To attach a vendor to these products, we use a specific SharePoint data type called a lookup column. This diagram represents how the lookup column works. It extends a tether from a single product node and locks it securely into a specific supplier node. This tether forces the application to only accept pre-approved vendors. A user cannot type a random company name into the product record. They must select from the official list. This crucial relational link is the specific mechanism that transforms raw data into a governed, error-proof operational system. The final piece of our backend architecture is the stock transactions list. We build this exclusively to track every distinct stock in and stock out event. Each row here is a single movement of goods. We need a choice column for a transaction type, like stock in or stock out, a number column for the quantity moved, and a choice column for the reason, such as a sale or a damage report. To tie this movement to an actual item, we create a second lookup column. This time, we point it directly to the master products list we just built. This solves a major vulnerability. If a user simply overwrites the current stock number on the master list from 50 to 40, the business has no idea where those 10 items went. By forcing every stock change to be recorded as a new row in this transactions list first, we maintain a complete, unalterable history of exactly who moved what, when, and why. We now have a unified 3-list architecture: suppliers feeding into products, and products feeding into transactions. Because the data is strictly separated, our Canvas app can now dynamically update stock levels, map transaction history for reporting, and accurately trigger Power Automate workflows when a specific item hits its reorder point. But as the system is used, the transaction history will grow. Once a SharePoint list reaches thousands of records, Power Apps can struggle to filter the data, a performance issue known as a delegation warning. This view shows the SharePoint indexing menu. To maintain performance, we need to index the product ID and status columns, allowing SharePoint to process large queries before sending results to the app. This robust data foundation guarantees the front-end application will run flawlessly, and it sets the stage for us to begin building the visual user interface in the next sequence.